Good afternoon to one and all. This is Marie Pushpam, and for today's class, we are going to see the components of nuclear reactor, then types of nuclear reactor. Then coming to the types of reactor, there are two types. One is said to be power reactor, which is said to be the nuclear reactor. Another one is the breeder reactor. So I'll repeat. So things we are going to see for today's class: components of nuclear reactor, followed by types of reactor. In types of reactor, two types are there: power reactor, another one is breeder reactor. So I'll start with nuclear reactor components. So all of us know what is said to be a nuclear reactor. So if you take nuclear reactor, it's a device used to generate electricity by the expense of heat energy released by nuclear fission reaction in a controlled manner. So this apparatus we call it as nuclear reactor. Is it clear? So nuclear reactor is an apparatus which generates electricity at the expense of heat energy by fission reaction in a controlled manner. Is it okay? So now we can see the components of nuclear reactor. We have 6 components. The first one is the reactor fuel. So what do you mean by reactor fuel is it's a fissionable material. For example, uranium-235, thorium-232, plutonium-239. So these are the different reactor fuel. They are used in the form of rods. Second one, moderator. During nuclear fission reaction, fast neutrons are being produced. So if you take fission reaction, I have explained in the last class. So during fission reaction, fast neutrons are being produced, and these fast neutrons are slowed down by substances like heavy water, graphite, beryllium, as well as beryllium oxide. And these substances which slow down the fast moving neutrons into slow moving neutrons, we call the thing as moderator. Is it okay? An example of moderator: water, that's heavy water, graphite, beryllium, and beryllium oxide. And third component is reactor coolant. So it's nothing but coolant. And you know what's the purpose of the coolant? So if you take the nuclear reactor, nuclear fission reaction is said to be a reaction which involves large amount of heat. So the reactor becomes very hot. So to make the reactor cool, what we do there is we use coolant, substance called coolant, to cool the reactor. So substance used as coolant are water, air, carbon dioxide, helium, as well as molten sodium. So water, air, carbon dioxide, helium, and molten sodium are used as coolant, and this cools the reactor. Next one is said to be the control rod. And the purpose of control rod is to absorb the neutrons, because if you take nuclear fission reaction, 3 neutrons are produced in normal fission. 3 or 2 neutrons will be produced. So leaving 1 neutron for continuous reaction to take place, and the other 2 neutrons are, 1 neutron is being absorbed by a rod which is said to be control rod. And normally the control rod used in a nuclear reactor are cadmium and boron are used as control rod. Is it okay? So what do you mean by control rod is nuclear fission reaction, neutrons are being absorbed. 3 neutrons are produced in a single fission reaction, but we need only 1 neutron. If it is not controlled, it becomes the principle for atom bomb we have seen in the last class. So we have to make this nuclear fission reaction as a controlled nuclear fission reaction, so that it generates electricity. So what you have to do there is you have to control we have to absorb the neutrons. So neutrons are being absorbed by rods called as control rods, and these are nothing but cadmium and boron are used as control rods, and they are also called as arresters because they slow down the fission reaction. Is it okay? Next one is neutron reflector. The surface of the reactor is covered with a material which scatter neutrons. I'll repeat. Reactor surface pathina, it's covered by a material called as reflector, which is used to scatter the neutrons. So neutrons flux populations thus increased in the interior of the reactor, and these are called as neutron reflectors. They are called as neutron reflector. They scatter the neutrons, so they are called as neutron reflectors. And last one is reactor shielding. If you take the nuclear reactor, large amount of radioactive rays will be emitted. So the leakage of hazardous neutrons and gamma rays is stopped by surrounding the reactor with a wall of concrete and lead. And this is of about 6 to 8 feet thickness, and this lead would absorb neutrons as well as gamma rays, and this we call it as reactor shielding. So the purpose of the shielding is to prevent the leakage of neutrons as well as to gamma rays from the surrounding, because the environment will be affected, and people in the environment will be also be affected by this radioactive rays. So to prevent from that, normally the nuclear reactor is surrounded by a thick wall which is made up of concrete and lead, which is of about thickness 6 to 8 feet. And this, the purpose of using lead here is the lead will absorb the neutrons as well as the gamma ray. So these are the components present in nuclear reactor. I'll repeat the components. The first component is a reactor fuel, uranium-235 or plutonium-232, or uranium-235, thorium-232 and plutonium-239 are used as reactor fuel. Coming to moderator, heavy water, graphite, beryllium and beryllium oxide are used. Coolant, third one is the component is a coolant, water, air, carbon dioxide, helium and molten sodium are used. Then control rods, cadmium and boron are used. Coming to nuclear reflector, they scatter the neutrons. And last one is reactor shielding, that's a concrete wall of concrete and lead is used. It is of about 6 to 8 feet thickness. So these are the different components present in a nuclear reactor, and I have said you the purpose of the nuclear reactor is nothing but produce electricity by nuclear fission reaction in a controlled manner. Is it okay? So next we are going to see the types of reactor. So coming to the types of reactor, there are two types. One is said to be the power reactor, which is nothing but the nuclear reactor which is used to generate electricity. And second one is a breeder reactor, which converts a non-fissionable material into a fissionable material. So a non-fissionable material is being converted into a fissionable material using breeder reactor. Is it okay? So in detail we can see the nuclear reactor, or it's otherwise called as power reactor, and also breeder reactor. First I'll start with power reactor. So coming to this nuclear reactor or power reactor, the heat is being liberated in nuclear fission reaction, which is used to generate electricity in the power reactor. The nuclear core contains uranium rod. I have said you already, that is your fuel is immersed in a pool of heavy water. Heavy water is nothing but a coolant embedded in solid graphite or beryllium, which is acting as a moderator, and the fuel is subjected to fission by slow neutrons. Fission by slow neutrons. Is it okay? And the fuel is subjected to fission by slow neutrons, and the chain reaction prevailing the reactor is controlled by cadmium and boron. Cadmium and boron. Is it clear with the point? I'll repeat. So if you take the power reactor, we have uranium as the fuel rod, which is immersed in a pool of heavy water, and this is being kept inside the moderator, which is solid graphite or beryllium. Solid graphite or beryllium. And now the fuel is subjected to fission reaction by the slow neutrons, and the chain reaction is controlled by cadmium and or boron rods. We have rods inside, control rods, which controls the nuclear fission reaction, and coolant absorbs the heat produced in the reactor. The coolant absorbs the heat produced in the reactor. Thus the heat thus absorbed is used to convert water into steam, which runs as turbine and produces electricity. I'll explain this with a diagram. So if you take this one, the thing shown here is, you have the apparatus, the fuel rod is present, the thing which is a colorless thing which is present inside is said to be the fuel rod, and the fuel rod is packed inside the moderator, and inside they are kept inside the coolant. Is it okay? So the outer wall is said to be the reflector, and the most outer thing we call it as the shielding, and above the fuel rod and the moderator is connected to a simple thing which is called as control rod. Now the coolant is being water is present inside, and that is being heated because of the heat generated by the nuclear reactor, and this heat will be circulated. If you take outside, the water is kept there, and the heat produced by this water is absorbed by the water which is present outside, and we are putting inside water from downward, and the upward it is coming in the form of steam, and that steam will run the turbine which is used to produce electricity. Is it clear? I'll repeat once again. So see the picture very clearly. So if you take the diagram, we have fuel rods. The fuel rods are kept inside the moderator, and the fuel rod is connected to the control rod which is kept above. 3 rods are shown above, that is said to be the control rod. So this connection is kept inside the coolant. Coolant is nothing but water. Is it okay? So it's kept inside the coolant. Now if you take the all this together is kept inside a shielding which is said to be the reflector. Is it okay? If you take the outer wall which is said to be the concrete shield of concrete and lead. So if you take this reflector, it is connected with a pipe outside, and in this pipe the coolant is being circulated. So heat generated by the reactor will pass into this, and outside we have kept a container, and that container contains cool water. And if you circulate cool water from down, which is coming outside from the top as steam, because this heat generated in the reactor is transformed through this pipe, and that heat will be absorbed by the water, and the water, cool water which is coming outside in the form of steam, and the steam which is coming there, a turbine will be placed. That is not shown in the figure. The pipe of the steam is connected to a turbine, and this steam will may run the turbine, and the turbine will produce you electricity. So this is the functioning of the nuclear reactor. So next thing we are going to see. So if you take this one, the nuclear reactor, the major power stations of this nuclear reactor are located in Tarapur, which is nothing but Maharashtra, then Rana Pradeep Sagar, which is present in Rajasthan, then Kalpakam as well as Kudankulam. We know these two are present in Tamil Nadu. So these are the various, we have a lot of nuclear reactors aforementioned here. There is Tarapur, Maharashtra, Rana Pratap Sagar, which is kept in Rajasthan, then Kalpakam and Kudamkulam are present in Tamil Nadu. So next thing we are going to see is said to be the breeder reactor. I have said you already. So breeder reactor is a reactor which produces fissionable material from non-fissionable material, and the fuel produced here is said to be the breeder reactor. So breeder reactor is a reactor which converts a non-fissionable material into a fissionable material, and the example we are using here is uranium-238. I have said in the last class itself. So if you take uranium-238 is converted into a fissionable material plutonium-239 by neutron reaction, which is done inside a breeder reactor, and the reaction taking place is, if you take uranium-238, it is heated by a neutron which produces uranium-239 plus gamma rays. Then this uranium-239 undergoes disintegration to give you neptunium-239 plus a electron. Then neptunium-239 undergoes disintegration to give you plutonium-239 plus electron, and this plutonium-239 is said to be a fissionable material. Thus if you take the overall reaction, Uranium-238 is hit by a neutron to produce, it's a non-fissionable material, so we call it as a fertile material. Uranium-238 is said to be a fertile material because it is a non-fissionable material. We call the thing as a fertile isotope. So coming to this fertile isotope is hit by a neutron to give you plutonium-239 plus 2 electron plus gamma ray. So this is the overall reaction taking place inside a breeder reactor. So I'll repeat this breeder reactor once again. So breeder reactor is a reactor which converts non-fissionable material into a fissionable material, and the example explained here is uranium-238 is being converted into plutonium-239, and uranium-238 is a non-fissionable material which is called as fertile isotope, and plutonium-239 is a fissionable material which is said to be a fissile isotope. Is it okay? So I'll repeat the thing what you have seen for today's class. So first I have explained you the components of nuclear reactor, then the functioning of nuclear reactor is explained in the sense of power reactor. Finally, I have explained you breeder reactor which converts non-fissionable material into a fissionable material. And I think you are able to understand the class. Thank you for listening. Continue studying. Thank you, ma'am.